and I hope you're having a great day so far. As usual, Peter's deflected some questions to me, which I sneakily heard him online before I just started. So I'm not entirely sure what the questions are, but I'll deflect them back to Pete. So I'm going to talk to you about the economic and environmental benefits of bio-based, biodegradable and compostable chemicals and materials. I'll do a brief introduction to the BBIA and what we do, talk about how this really is a once-in-a-generation opportunity, talk about the role of bio-based and biodegradable chemicals and materials, what the size of the prize is, some barriers to the transition away from fossil resources, and then how we can unlock the opportunity. So in terms of the BBIA, we're a trade association focused on accelerating the adoption of bio-based, biodegradable and compostable chemicals and materials, ultimately to reduce our reliance on fossil resources and create a sustainable circular economy. And we do that through our 4 key pillars. The first one is influencing, so working with government and policymakers to try and promote and advocate for policies that support the growth of the bio-based sector. The second is through our innovate pillar, where we either get involved in or help bring together consortia to carry out innovative R&D projects. We provide a platform for organisations to connect and collaborate, share ideas, and to really have one voice for the sector, and then communicate. So we try and share information and educate around the benefits of the sector. So really, I want to talk about how this is such a cool time to actually be alive at the moment, and we've got a once-in-a-generation opportunity. So this once-in-a-generation opportunity to regenerate our industrial heartlands, driving a just transition away from oil and gas, creating a resilient engine for net zero, and securing and growing highly skilled and productive jobs in the UK. And how are we going to do that? Well, we want world-leading sustainable chemicals and materials developed, designed and manufactured in the UK. Without sustainable chemicals and materials, there can be no sustainable, resilient, modern society. They're in everything we use in our daily lives, from plastics, food, textiles, renewable energies, batteries, medicines, you name it. And they ensure our food security, provide the clothes that we wear, heat our homes, provide national security, enable communications and deliver treatments for life-changing diseases. However, as we all know, chemicals are made from fossil oil and gas and are responsible for nearly 10% of all greenhouse gases today. And unlike energy, which can be generated from non-carbon sources such as wind and solar, chemicals production requires carbon as a feedstock, since it's integral to the composition of chemicals. So what's the challenge? I'm sure Pete's already taken you through some of this, but for the past 70 years, the chemicals industry has benefited significantly from the abundance of inexpensive crude oil and natural gas as a feedstock, and they're very, very efficient in the use of that. And inherently, sustainable chemicals come with a green tax. Because those sustainable feedstock sources, they're more expensive than oil, they usually require some kind of pre-treatment, and sometimes the technologies aren't yet proven at scale. But if we want to continue living our lives in the same way, but be more sustainable, we've either got to completely change the way the chemicals are made, or we need to think about different inputs into the production to be more sustainable. And there's 2 solutions, and we should be considering both of these equally. So the first one is using our conscience, reducing consumption, reducing waste, recycling. And the second is around more sustainable materials, products and processes. So I think Pete's probably shown you this slide from the report that we did, but there's several ways that we can reduce waste and greenhouse gases for the chemicals industry. And I'd like to talk to you about the sustainable feedstocks part today. So again, you've probably seen this earlier from Pete, but the 3 different options for the sustainable carbon feedstocks are biomass, recycled carbon, and then carbon dioxide. So then how do we have the role of bio-based chemicals and materials? Well, the biomass and the circular economy are essential for us moving forwards to reduce our reliance on fossil resources. So we urgently need to create a circular bioeconomy which focuses on using carbon which is already above ground. And bio-based, biodegradable and compostable materials do this, and they help decrease our reliance on fossil carbon. Importantly, at the same time, they can help boost soil fertility by returning biowaste and nutrients in the form of high-value compost back to nature. Several different types of biomass that are available. I'm sure you're all aware of some of these, but it's not just about crops that we could be using for food instead. There's lots of waste residues that we need to be thinking about, which we can use. An example here, 9.5 million tonnes of food waste annually every year in the UK are created. Obviously, we want to try and reduce that amount of food waste, but we also want to prevent that food waste from going to landfill and being wasted, because actually, when food goes to landfill, it creates methane gas, which is more potent than CO2 as a greenhouse gas. And each year, our food waste accounts for 30% of the UK's methane emissions. So there's two ways we can use biomass as a feedstock. This is a diagram which came from the Super Energy Hub's recent report on carbon for chemicals. So we can feed biomass into the existing chemicals industry in the form of drop-in bio-based chemicals, or we can create novel bio-based chemicals, which a lot of the time have new, novel, superior qualities, and we can do that through dedicated biorefineries. And what's important here, sorry, this is a little bit blurry, this picture, is that by using biomass and producing bio-based chemicals and materials, what we're doing is we're using the carbon dioxide that's already above ground, fixing it into biomass, using that biomass to create chemicals and materials, and then at the end of life, it's being released back into the atmosphere, but there's no real net gain in CO2 into the atmosphere, whereas with petrochemicals, we're usually digging up carbon from underground, and at the end of life, releasing that into the atmosphere, and that's actually increasing the net amount of CO2. So what are kind of bio-based, biodegradable and compostable materials? What's the difference? Well, a bio-based material can be wholly or partly derived from biomass. A biodegradable material is capable of undergoing biologically mediated decomposition, and a compostable material can undergo biologically mediated decomposition, but it has to be in industrial composting conditions. So that's sometimes where some confusion comes in, but compostable materials are not meant to be designed to be released into the open environment. They need to be treated in a composting facility. And then we have attributed bio-based materials, and that's where mass balance is used to attribute a certain proportion of biomass to a product. And it's really important that when we think about bio-based, biodegradable and compostable materials, that we have the right application for the right problem. So I would suggest that bio-based materials should be used when they're better for the environment than their fossil counterparts. And we really need to consider the full life cycle assessment, toxicity, water usage, and biodiversity as a whole when we're thinking about that. Biodegradable materials, they should be used when we intend to release something into the open environment where it can't be easily retrieved. And some great examples of where this is happening is with agricultural mulch films, biolubricants, polymers and liquid formulation. And then for compostable materials, we really want to use these when we're trying to save organic wastes from going to landfill, for example, food waste, or when materials are too small or flimsy and they're hard to recycle in any other waste streams. So biodegradable mulch films are a great example. You will have probably seen it across the fields of the UK. Farmers cover their products sometimes in plastic, moisture content in, and it helps plants grow better. But inevitably, when that plastic comes to its end of life, it sometimes ends up being persistent in the environment. Whereas if we use biodegradable materials, they can be ploughed in after use. They then degrade down into nutrient-rich compost, and that benefits the soil fertility. So polymers in liquid formulation, some snaps here from the wonderful report that Andrew and her team have put together. We know that polymers and liquid formulations are a huge sector, 1.27 trillion. And actually, it's interesting that 85% of that each year is predicted to be in paints and coatings, inks, etc. So what are the benefits of bio-based coatings, paints and inks? Well, bio-based coatings are formulated using that biomass, that renewable raw materials. So that reduces our reliance on fossil resources. They can be designed to be biodegradable, which reduces their environmental impact. They can be designed to be low toxicity, which helps with improved indoor air quality, especially if you're getting involved with painting and things like that. Advancements in their coatings have led to improved performance, which can even be superior to traditional fossil incumbents. And it can support local domestic agricultural industries by promoting supply chains and the growth of biomass and crop rotation. And here, I don't know if you can see the small detail on this slide, but here's some examples of where bio-based polymers have been created for paints and coatings. And it shows on the right-hand side in the far column those properties which are improved above their fossil incumbents. So there is some best practice going on abroad in the paints and coating sector. So in the Netherlands, they have a sustainable procurement catalogue. Basically, the higher the percentage of bio-based raw materials, the higher the value is of the tender when someone puts a tender in for a project. And in Switzerland, they have a labelling system which allows you to easily see on a product how much of that product is bio-based and its kind of sustainability criteria, with A being the greatest grade. So really then, we've got an opportunity here, but what's the size of the prize? Well, you will have seen this earlier from Pete, but the UK chemical sector has an ambition. So by 2050, we'll have doubled in size, but significantly lowered its greenhouse gas emissions, sourcing 80% of its carbon from non-virgin fossil sustainable carbon resources. And you can see here on the right-hand side, 30% of that sustainable carbon will come from biomass. And actually, if we could manufacture 30% of UK chemicals from bio-based, from biomass, there's potential for upwards of 204 billion annual revenue for the UK every single year. And that is a huge opportunity that we really should be taking advantage of. And there's another study that I was fortunate to be involved in for DESNES, looking at the economic and climate benefits of the increased use of bio-based chemicals. This hasn't yet been published, but will be soon. And we showed through this that production of just 2 million tonnes of 15 bio-based chemicals in the UK has the ability to contribute to over 5 million tonnes of CO2 savings annually to the economy. And that was utilising less than 24% of the UK's biomass with no land changes to growing biomass. So that's really significant. And this 5 million tonnes is also a significant number because the amount of CO2 that was saved through the road traffic fuel obligation in 2021 was around that amount. And that was created through a policy mandate. So we're hopeful that having this information now through the DESNES study could lead to some policy changes where hopefully bio-based content of chemicals will be a mandate in the future. So what are the barriers to the transition? Well, recently carried out a 6-month Innovate UK project looking at the barriers to the commercialisation of these products, spoke to over 200 different stakeholders and organisations, and I don't suppose any of these on here will be a surprise to anyone, but the cost of bio-based is usually higher due to the feedstocks. Sometimes there can be performance issues and technical issues because it's a nascent sector. There's issues with supply chain integration and logistics. There's definitely competition for biomass, say, for example, with sustainable aviation fuels or biomass for energy. Market acceptance and consumer awareness isn't quite there yet because it's quite a complicated area and it's hard for people to get a grasp of. There are some environmental impact uncertainties, and the infrastructure and end-of-life management for some of these materials isn't quite there yet. In terms of the policy and regulatory environment, it's very, very complex for bio-based materials. All of the 7 ministerial departments have a role to play in this. And I think, as Pete was saying earlier, that's because no one really has this overarching responsibility for net zero and for the UK's kind of carbon budget. So out of the 606 government departments and agencies, around 60 of those are involved in the commercialisation of bio-based and biodegradable materials, making it really difficult to navigate. This diagram here shows the bioeconomy circle, and around that I've plotted the policies, regulations and standards which are detrimental to the commercialisation of bio-based biodegradable materials, and that's colour-coded by department. So you can see that a lot of it is controlled by DEFRA and then also by DESNES. And again, just plotted here the effect of that strategy, policy or regulation on the commercialisation of bio-based materials. and then the impact of that. So in the top left-hand corner, we can see that, again, colour-coded DEFRA and DESNES, and then Her Majesty's Treasury as well in there as really the key policies that need to be removed or revised in order for bio-based materials to really thrive in the UK. There has been strategy for the bioeconomy and bio-based materials in the past. There was the Growing the Bioeconomy strategy. Unfortunately, that was withdrawn and replaced with the UK Innovation Strategy and then the Net Zero strategy. And actually, the Innovation Strategy did state that where fossil-derived fuels or plastics are required, biomanufacturing will deliver bio-based and waste-derived alternatives in 80% of the cases by 2035. So quite a strong statement there in 2021 from the Department of Business of Energy at the time. However, that hasn't actually been translated into any policy or regulations for the bio-based materials and chemicals. Again, the NHS produced a Delivering a Net Zero National Health Service strategy, and that has a quote in there anticipating that bio-based polymers will produce significant savings, but again, not seen any of that come to life. And kind of more recently, the government signed up to the Ellen MacArthur Global Commitment and the UK Plastics Pact, and stated it would incentivise the use of reusable, recyclable or compostable plastics. And again, particularly for the compostable plastics bit, haven't really seen that strategy come through into policy and regulations. So what can we do to unlock the opportunity? Well, the UK is the home of significant and long-standing academic excellence in bio-based chemicals, which means that we do have this great potential to be a leader in the space. But other areas of the world are already implementing policies to drive the sector forwards, and we're rapidly losing our competitive advantage. So, to produce world-leading sustainable chemicals that are developed, designed and manufactured in the UK, we're calling on the government to establish a chemicals roadmap, which really has the chemical sector at the heart of that, and also providing investment for new biorefineries and ring-fencing 25% of national non-food biomass feedstock to produce sustainable bio-based chemicals and materials. So really pivoting that focus away from bioenergy to really using biomass for the production of bio-based chemicals and materials. We'd like to think about how we can reshore chemicals manufacturing to the UK. So for that, we need dedicated scale-up infrastructure that helps our kind of homegrown talent develop in the UK, and that needs to be affordable and open access. We really need to create a level playing field. So as I've said, the bio-based chemicals and materials come with a green tax, but what we actually want to do is remove those hurdles. And one suggestion is that for the plastics packaging tax, that recycled content also includes bio-based content, meaning that bio-based plastics would be exempt from that plastic packaging tax, and that we should promote the mass balance approach for biomass in these materials in the short term whilst we transition. We really need to regulate for national resilience. So as I said, it's a really, really complicated environment, but we really need to revolutionise that, take away those barriers and really promote the adoption of sustainable bio-based chemicals and materials. And lastly, we think the government should be leading by example. And here we think there should be a bio-preferred programme implemented, and that by 2030 there should be a mandate that 30% of chemicals and plastics procured by the NHS should be made from sustainable bio-based chemicals and materials. So the UK bio-based chemicals and materials sector is ready, but we really just need the government to support us to develop this so that we can remain a resilient modern society. So then, just a final thought. I've been through lots of presentations recently and lots of events, and people are still talking about waste. And I really think we need to change the conversation here, because there should be no such thing as waste. It should be seen as a resource or a feedstock that goes into another process. And I think if we can change our mindset, then we can start to move to a really truly circular bioeconomy. I've got a picture of the bin man coming here. So when he comes to our house every week, I've got my daughter into thinking it's the feedstock man who comes. So that's the kind of thing that we need to be doing, and inspiring the generations to come that there is no such thing as waste. And then, yeah, the greatest threat to our planet is the belief that someone else will save it. So I think someone asked Pete a question earlier. around who should be responsible for this, who should be the overarching body. And whilst I agree there should definitely be a government department that takes control of net zero and our carbon accounting, I do think that we all have a role to play in that as well. So thank you so much for listening to me. Really sorry I couldn't be with you today. My contact details are on the screen there, and I hope you enjoy the rest of your day.
Thank you very much, Jen. Are you... thank you very, very much, despite not feeling so well. You've engaged with us, so really appreciative of that. Are you okay to stay around for a couple of questions, if that's okay?
Yes, as long as they're not from Pete.
We can take that one offline. So are there any questions? Oh my goodness. Okay, Andreas, your hand went up first. So we have Andreas Kunkel, Vice President of BASF. First question is from Andreas.
Thank you for this presentation. My question is...
Can you hear, first of all, on that microphone?
Yes.
Yeah.
Sorry, Andreas.
Yeah.
What is the feedback or commitment of UK politicians to your proposals for the transition so far?
Yeah, so we've had lots of conversations with various different departments, and I think we're definitely gathering the data and evidence that we need to be able to show why this is such a valuable sector. And I think definitely with the new government, we've had a lot more positive conversations. There is a circular economy task force that's being set up through DEFRA to represent a cross-department approach to the circular economy. And we've been talking a lot with them around how the bioeconomy fits into it. And that's been something that we've never really been able to talk about before, because it's been seen as a very separate thing from the circular economy. And then also with the engineering biology strategy and vision that's in place, and the fantastic appointment of Minister Valence as well. He's really switched on. He really believes in the bio-based sector. So we're hopeful that we'll see some changes. The kind of UK Regulatory Innovation Office, known as RIO, has also just been established. And I had a conversation with one of their policymakers last week, and they're really keen to hear from industry and from trade associations around what are the low-hanging fruit and the key kind of regulations changes that could happen quickly to make significant changes. And we fed in all our suggestions there around the plastic packaging tax, around ring fencing biomass, and we continue those conversations with them. And hopefully when we get into the new year and we see some new strategies published, there will be a lot more mention of the bioeconomy in those. Not sure if that answered your question.
Tanya Sheridan, Head of Policy and Evidence at the RSC here. I was going to ask you what you saw as the skills, opportunities and challenges for the future workforce from a transition to more biochemicals, and what skills shortages and challenges, or indeed opportunities, you're hearing about from the businesses you talk to in the sector.
Yeah, that's a great question. So it's primarily fermentation skills, so bioprocessing skills. And that's not necessarily at the technical end, it's more at the operating end. So lots of companies are trying to scale up and scale out, and they can't find people with the expertise to actually run the plant, the actual operators who understand enough about the science, but also understand how the kind of the mechanical aspect of it works. So I do think there's a large gap in that kind of manufacturing operating space, which hasn't really been helped by Brexit and the visa requirements, etc. So fermentation skills, operating skills, and then I think also then at the digital end. So as we try and transition to more continuous bioprocessing for the production of some of these materials, online monitoring, digital, AI, all those kind of skills, where you need someone who understands biological processes, but is also very good with kind of computational sciences. I think that's an area where we should really be focusing on developing our talent.
One final question, maybe we want to take that one last. Jen, just one more question. Thank you.
Thank you. Natalie Valeton from Dow. You pointed in your presentation that there are some linear use of resources and there is a need for circularity. And through your example of food waste, for example. And I wanted to hear further what are the key systematic changes, because there was a call for system changes earlier on today that you would see as a trigger that is needed to enable that transition.
Yeah, so I think particularly with food waste, obviously we've got the simpler recycling guidelines that are going to come in the next couple of years, which will mandate that people have to have food waste collection from their homes, which is fantastic. So hopefully either that will make people realise how much food they're wasting and reduce it, or that food waste will be collected, which will potentially then be organically recycled. At the moment, there are biomethane subsidies, which prefer that food waste goes to anaerobic digestion. And actually, what I believe we should be concentrating on is that food waste going to in-vessel composting to create nutrient-rich compost, which we can then use to replenish our soils, which we've degraded over the kind of past decades. But either way, food waste needs to be collected and it should be turned into something. So whether that's anaerobic digestion for biomethane production, and then the digestate can, depending on the time of year, be spread on farmland, or it could go through anaerobic digestion if it was a dry facility and then be composted. The digestate could then be composted. So I think they're the changes that we need to see in order to maximise the value of our food waste. It's around investment in infrastructure for in-vessel composting in the UK.
Sure. Thank you, Jen. We'll let you go and take some rest. Thank you for joining us online. Thank you. And take care. Bye-bye. And thank you, everyone, for your attention this morning.